Howdy, today on Flipping Science we're looking at redox. So understanding redox reactions is very important in chemistry. Redox reactions are reactions that involve reduction and oxidation, and we'll talk about what those terms mean shortly. Most reactions are redox reactions. So examples down here, we have Elmo combusting, so combustion reactions. They're redox reactions. Here we have a battery running a very easy small motor. All the chemistry involved in batteries are redox chemistry. So it's redox reactions going on involved in batteries that cause batteries to do what they do. So chemistry is the domain of the electron, and redox reactions are about electron exchange. So who is giving an electron to who? That's really the question. Reduction and oxidation go together. You never have one without the other, because in one reaction you have an electron being given off, and in the other reaction you have the electron being taken in. So that's reduction and oxidation. The electrons that are lost in an oxidation reaction, so oxidation is loss, they're gained in reduction reactions. Reduction is gain. So we're going to focus on those terms there and focus on what electrons are doing. So let's have a look at what happens in an oxidation and a reduction reaction. So we're going to start by looking at oxidation. Now there's many different ways you can define what oxidation is. We could say it's the gain of oxygen, the loss of hydrogen, the loss of electrons, or an increase in oxidation number. We're going to focus mainly on these last two in the unit that we're doing. So gain of oxygen, loss of hydrogen, loss of electrons, increase in oxidation number. And the way I remember this is oxidation is loss, OIL. So it's loss of electrons, because I'm focusing on the electrons, that's what I care most about. So oxidation is loss of electrons. Reduction is the opposite of oxidation. So we can define it as the loss of oxygen, the gain of hydrogen, the gain of electrons, and a reduction in oxidation number. And again, we're probably going to focus mainly on these ones down the bottom here. The way that I remember this is RIG, because I'm going to focus on the electrons, so reduction is gain of electrons. So when a substance gains electrons in a chemical reaction, that is a reduction reaction. It is being reduced. So oil rig, that's the way I remember it. There are other mnemonics you can use. Leo says GER, but oil rig I think is the easiest one. I think one of the hardest bits of redox is getting the terminology correct. So we're going to start by looking at an oxidant. So if substances gain electrons easily, that means that they cause oxidation, and that's the loss of electrons. So something that gains electrons is reduced, but it causes oxidation. So because it's causing oxidation, it's called an oxidant, which is a portmanteau of oxidizing agent. So an oxidant gains electrons easily and causes oxidation, but it itself is reduced. So a substance that causes oxidation is easily reduced. Conversely, something that is easily oxidized loses its electrons easily, so because it's losing electrons easily, it causes reduction. So by losing electrons, it causes reduction, because remember, reduction is the gain of electrons. So a reductant, which again is a portmanteau of reducing agent, a reductant loses its electrons easily, it causes reduction, but it itself is oxidized. So if something causes reduction, it is being oxidized. Let's look at an example down here. Down here we've got iron being oxidized to iron 2 ions, and we have copper 2 ions being reduced to solid copper. So iron is being oxidized. It is losing 2 electrons to become iron 2 plus, so iron 2 plus iron. The copper ions are gaining 2 electrons here to become solid copper. So the copper ions are being reduced to copper. So therefore, because the iron is being oxidized to iron ions, it is causing the reduction by losing its electrons that are gained by the copper. It is losing its electrons, and therefore the copper is being reduced. So it is a reducing agent because it is causing the reduction of the copper ions. So iron is a reductant. The copper ions are gaining electrons, they are being reduced, and because they are being reduced, they are gaining the electrons that are given off from the iron. So because they are being reduced, they're causing the oxidation of the iron. So the copper ions are an oxidant because they're causing the oxidation of the iron to the iron ions. Let's have a look at another example. So here we have an oxidation reduction reaction occurring again at the same time. We've got zinc reacting with hydrogen ions to produce zinc ions and hydrogen gas. The solid zinc over here is being oxidized to zinc ions. So it is losing its 2 electrons from the outer shell, and it's making the zinc ions. Okay. The hydrogen ions are gaining the electrons from the zinc and producing hydrogen gas. So the hydrogen ions are being reduced to hydrogen gas. So here are the questions. Which substance is losing electrons? Which substance is gaining electrons? Which substance is the reductant? Which substance is the oxidant? So let's have a look. The zinc is losing electrons to produce zinc ions. So it is being oxidized. Because it is being oxidized, it is causing the reduction of the hydrogen ions. So the zinc is the reductant here in this reaction. The hydrogen ions down here are gaining electrons to produce hydrogen gas. The hydrogen ions are gaining the electrons that are given off from zinc. So the hydrogen ions are being reduced to hydrogen gas. Because it's being reduced, it is causing the oxidation of the zinc. It is taking the electrons from the zinc to produce the zinc ions, and those electrons that are being taken from the zinc ions are going to the hydrogen ions to produce hydrogen gas. So the oxidant is the hydrogen ions. So today on Flipping Science we looked at oxidation and reduction, what they are, and some simple definitions. That's it for Flipping Science today. See ya.